let's try this now. All right. Class?
Yes.
Okay, so pretty good, pretty good. Sounds almost like you're excited to be here. Now, for this right here, sum of differences, the reference sheet has all your formulas written as S and T. Your two variables are S and T. My notes that I have up here, it is A and B. But you're going to see it both ways, with S and T or A and B. But it just means your first number and your second number. So we've already been doing the cosine. Now we're going to do sine and tangent, where, again, I said tangent's a pain. This is sine, blah, 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 blah. Okay, here's the formula. Okay, like I said, mine's going to have an A and B. Yours has an S and T. And okay, one thing that you might also see it as, because I don't like writing it in this way, because I don't know why. I can never remember it like this. So the way I always remember it is sine A cosine of B plus sine of B cosine of A. It means the same thing. It's just these two over here I put backwards because my other ones have a pattern. It was cosine, cosine, then sine, sine. So the pattern on this one is sine, cosine, sine, cosine. Does that make sense? That's the way I always see it, and I have to try and remember it like that. So same thing for this. So it would be sine A cosine of B minus sine of B cosine of A. And pay close attention to the signs that are in between them. Because for those previous ones, the cosine A plus B gave me a minus sign, right? It was always opposite signs. But this one, it doesn't. And a lot of people had trouble with that when we were doing it earlier. Okay? So we're just going over this. And the next one is going to be tangent, which is a hot mess. And I hate doing it. I really do. I've done this before, tried to prove it, but everyone started zoning out after I started the first problem. So I stopped doing it. So I'm not doing that. I'm not going to do that either because this is ugly. I don't want to do that. So instead, I'm just going to give you this. So just, that's the formula, and plug it in where it goes. All right? So that's important. But now, if you have your unit circle out still, there's one on your reference sheet, but a lot of people still like using the regular unit circle. You could use that too, that's helpful. Tangent is not on there, is it? No. Tangent is not on your unit circle. You're going to have to make some tangent values. Okay, because tangent is sine over cosine, right? Okay, good. So that's where we get right here. Tangent, sum or difference. Now, exact value of sine 75. So, sine 75 is not on my unit circle, right? It's not on the unit circle. I need two values that are on my unit circle. Two values. What do you got? 45, 30. Very good. So those added together, so it would be 45 plus, right? 45 plus 30. And it's important to have the symbol in between so I know which of the formula I'm going to be using. So now for this one right here, it's going to end up becoming sine of 45 cosine of 30 plus sine of 30 cosine of 45. Now, since these are known values, they are on the unit circle, and that's where I'm going to get them from. So I'm going to pick these numbers off the unit circle and replace them. Remember, sine is your y value, cosine is your x value. So sine at 45 is going to give me, very good, rad 2 over 2. Cosine at 30 plus sine at 30, cosine 45. There we go. Yes. Now we're going to multiply straight across because that's how we multiply fractions. So rad 2 times rad 3 is rad 6, and 2 times 2? Very good. Plus 1 times rad 2, and 2 times 2? Very good. Now, since they are common denominator, I'm going to combine over one denominator. So I'm going to just rewrite my answer as rad 6 plus rad 2 all over 4. And watch. You circle it, you know you're done. Questions, concerns, complaints? Conspiracy theory, yes. Huh?
It's just the same thing from last week?
Yeah, same thing. It's just we're just using a different equation. So we're just plugging in, and so we're going to end up having a lot of the same answers as what we had before, but it's coming out in different order. All right, are we good? Okay, so the next one is kind of a pain, but we will get through it. Now, starting off with tangent 7 pi over 12. Do we like 7 pi over 12? No, because we are on our phone at the time where Pacho was talking about it. So that would be super salty, wouldn't it? So 7 pi over 12. What do I do with the 7 pi over 12, right? What do I do with that? Very good. Multiply by 180 over pi because I don't like the radian because fractions are not my friends, right? So I'm going to multiply by 180 over pi to convert this to degrees. So I'm going to take my 7 pi over 12 and times by 180 over pi. What do we get? 105. So now what we're really looking for is the tangent of 105 degrees, right? So now looking at the numbers, it's easier to add them together as long as we're not on our phone. So it's almost like it keeps getting dark in here, and like shades happening because people just keep picking up their phone for some reason. I don't know why. So it's 105. So I want to find two numbers from my unit circle that are going to add or subtract to give me 105. 45 and what? 45 and 60, that'll work. So let's say it's going to be the tangent of 45 plus 60, right? Yeah. So I'm going to rewrite it with my 45 and 60 plugged in. So for my equation, it should be, what's it, tan 45. Is it plus or minus here?
Plus.
Plus tan 60. And all that's going to be over 1 minus tan 45 times tangent of 60. I always have trouble with this one because I can never remember it. I hate doing it. Now, I'm going to go off to the side because someone's on their phone again every time. So this is the third time. So next time I'm going to go confiscate me a phone back like, middle school age, right? I should do that, shouldn't I? Right? I know. I should like straight up like put it on blast. Confiscate the phone. So what we are going to do is, hey, yeah, right there. And you guys can go ahead. So new page. Tan 45. Now tangent is a ratio. What does tangent represent? Y over x. Y over x or sine over cosine, right? So I'm going to write this out so you guys don't have to do it every single time. So this is going to be sine of 45 divided by cosine, cosine 45, right? I don't know why I just changed blue, but you know what? It's fine. Sine 45. What was sine 45? We're at 2 over 2. Divided by cosine at 45, which was? We're at 2 over 2. And again, we have fraction over fractions, right? I do not like them. I do not like them here or there. I do not like them anywhere.
I was thinking that.
I was thinking the same thing too, right? Okay, I do not like green eggs and ham. I do not like them, Sam I am. So, we need to multiply by the... Very good. So, we're going to multiply by reciprocal. So, it's going to turn into the top. Rad 2 over 2 times the reciprocal of the bottom. So, I'll flip the bottom. 2 over rad 2. And what's going to happen there? Cancel. But is everything going to cancel? Yes, everything's canceling, right? And what are we going to get? Yeah. So, tangent 45 is always going to be, do I need to do this problem every single time? No. Because on your notes, what you just wrote down, you're telling me that tangent is 45. Tangent of 45 is 1, right? So, it's there in your notes for you. We are on example 1. Example 1, and we're like on a second slide, okay? So, this next part is, I'm going back to my red, is going to be tangent of 60, right? Well, it was 60, right? Yeah? Yeah. Okay. Sine 60 over cosine 60. It's always sine over cosine. Now, we have to start picking those numbers off by unit circle. Sine at 60 is rad 3 over 2 divided by cosine at 60, which is very good. And again, there's that fraction over fraction. Fraction over fraction. We do not like them. So, we're going to multiply by reciprocal to clean this up. So, it's going to turn into rad 3 over 2 times 2 over 1. 2 over 1, right? Because we flip over the bottom. And what's going to happen there? Cancel the 2's, which gives me just rad 3 over 1, which is still just rad 3, right? And I would keep it over 1 if I needed that 1. If I needed that still to be a fraction, I would keep it there. But in this case, I'm telling you, I don't need it. Now, do I need to go do tan 60 every time like this? No. Because you now know that tan 60 is rad 3, right? So we don't have to do this every time, but there's a couple of them that you're going to have to do on your own. Maybe like 30. You would have to do that one on your own. What's another one? Probably 90, 0, some of these other ones, right? Now, let's go back. So we're going to now plug in. So we said tangent 45 was 1. So I'm going to plug that in. So it's 1 plus tangent at 60 over 1 minus tangent 45 was 1 times tangent of 60, which was very good. So all we need to do is start cleaning this up. We'll work on an example. So I'm going to clean this up a little. Because 1 times rad 3 is just rad 3, right? Yes. Okay, good. Anyone see a problem here? Radicals on the bottom. Very good. Radicals on the bottom. So this technically is the correct answer. But my answer cannot be like this. Because I cannot have a radical in the denominator. So this one, since it is 2 terms, binomial over binomial, so we're going to have to try and clean this up. I'm going to go to a new page to do the work on this. So 1 plus rad 3 over 1 minus rad 3. Now, to get rid of the radical in the denominator, do you guys recall what do we got to do? No? Yeah, it's part of rationalizing, but this one is a special rational.
That was right.
I kind of heard something over here too. What am I going to multiply by?
Rad 3 over rad 3.
1 plus rad 3. Because I need to multiply by the conjugate. Remember the word conjugate. So I am actually going to complete this square on the bottom. Because when I do that, it's going to get rid of my radical. So we're multiplying by the conjugate, which is 1 plus rad 3 over 1 plus rad 3. Again, I am multiplying by the value of 1. Now, since I'm multiplying something by 1, I'm not changing the value. I'm just changing the way it looks. Because it's the same thing top and bottom. That's still just 1. Even though it looks weird. But we are rationalizing like this. And so now, since I have a binomial times a binomial, what's that special thing that you guys good at doing? Okay, hey, you guys are good at doing it. Okay, this is your jam right here, right? Okay, I'm writing it down here so we can go through and do this. So now we're going to multiply this out. That's what this is, multiplying it out. So let's start with the top. So I'm starting with the top. So first, that means the first times first, so it's 1 times 1. What is 1 times 1? Okay. Across, that means all the way across. 1 times rad 3. Positive, so it's a plus rad 3. Very good. Now, I is inside, so the inner 2 is going to be rad 3 times positive 1. Positive rad 3, so it's a plus rad 3, right? And L stands for last. So that one's going to be my last 2, which is rad 3 times rad 3. It's going to be just 3 because it gives me square root of 9, and square root of 9 is just 3. Is it a positive or a negative, though? Very good. So it's positive 3. Now, at the bottom, this is where all the magic happens. So we're going to fail this one again. So again, 1 times 1. Very good. Now, the next one, across, all the way across. So 1 times rad 3. So it's a plus rad 3. Very good. So inside, negative rad 3 times positive 1. Negative rad 3. And last, so negative rad 3 times a positive rad 3. Negative 3, right? Because it's going to give me a negative square root of 9, and we know square root of 9 is just 3, right? So, again, like I said, the bottom, this is where the magic happens. What's that going to do? Again, that just goes to 0, right? That just goes away. So that's going to be nice. That's going to go away. It disappears off of this. So that means that because that becomes 0, I'm not going to have any radical in the bottom anymore. So let's go ahead and combine like terms in top. Combine like terms in top. So what number goes first on top? 4, right? Okay, let's start with the 4. So it's going to be 4 plus 2 rad 3. Because we treat these like they are variables. So it's a rad 3 plus a rad 3. And how many rad 3s we got? We got 2 rad 3s. It's a plus. If it was a multiplication, then I would do inside together. But now I'm just combining it and treating it like it's a variable. So it's a 2 rad 3. All that's going to be over 1 minus, which gives me, yeah, negative 2, right? Negative 2. I heard it. So 1 minus 3 is going to give me negative 2. Now, this is all combined over one denominator, isn't it? Let's uncombine these. If we uncombine these, you could actually see what goes next. So to separate denominators, they're right here, they're common, and I'm going to separate them. So it's 4 over negative 2 plus 2 rad 3 over negative 2. Now from here, do you see what we could do from here? Okay, so I could actually reduce this now because I separated it over 2 different denominators. So 4 divided by negative 2 is negative 2, and right here it's plus, yep, very good, negative rad 3. So am I going to put plus negative rad 3? I could just put a minus, right? because those cancel. And I'm changing the sign from a positive to a negative there.
And then you done. You done, man.
Not done unless you put a circle around it. Does that make sense?
You
No?
know, it was a lot of work.
Yes, it is.
For that little
That's why I
piece.
said I don't like it myself. I don't even like doing it. I hate these ones. I'll do everything else but these. Seriously, I'll do on the next unit we have like half angle, and then there's double angle. I'll do those before I do this thing. I hate this one.
Why can't we leave it 4 plus 2 radical 3 over negative 2?
What did it end up doing right here? Starts with re, ends in. It reduced, right?
Oh.
That's why. Because I was able to reduce it, I separated each. So whenever you're doing this, you should be able to reduce it. I think it's like 90% of the time you're going to be able to reduce it. And 100% of the time that you're going to do these tangents, you're going to end up having to do all these steps too. You're going to have to multiply by the conjugate because you're going to end up with a radical in the denominator. Okay? So yeah, tangents are no fun because people on their phone for some reason.
Sorry.
Anyway, all right. So that being said, that was my answer for this one right here. So we came up with negative 2 minus rad 3 as my final there. Now, next example is 3. Or not 3, but C. So this is just like the ones we did last time. So I'm starting with it separated, expanded. So right here, I could tell, what are my A and B going to be? My A is going to be 40, and my B is 160. Very good. Now, I have to look at the format here. It goes sine, cosine, minus. Sine, cosine, minus. And I try to match it to which formula was used to get there. So the sine, cosine, minus was, I know it's going to be a sine, but what symbol goes in between? Minus? Yeah, it is going to be a minus sign right there. Because if I go back and check at my notes or look at my formulas, I can tell, all right, sine, cosine, minus right here, that means that there was a minus sign right there. For the sign problems, that's how it goes. Now from here, can we combine those? Yeah, let's combine those. So we're going to end up with sine of negative 120. But that's negative angles. Those suck, don't they? Now, you want me to show you a super cheater way how to get these?
Yeah.
A super cheater. But you gotta have your unit circle out for this to work. Okay, I will teach you how to be a super cheater. And wait till it's test time. I will show you even more. Okay. A whole new way to cheat on tests. You guys are be like, dude, you're my favorite teacher ever. Why don't we learn this before? Okay, now watch this. A negative 120, right? Isn't that the same distance as a positive 120?
Mm-hmm.
It's just in the other direction, isn't it?
Exactly.
So watch this. Let's go to positive 120. And since these are symmetrical, step 1, 2, 3, 4, and hey, look, 5. I'm at positive 120, right? So since I always start right here, to find negative 120, how many steps do I go? 5 in the other direction. Let's do that. 1, 2, 3, 4, and 5. So right here, this is my negative 120 degrees, isn't it? Is that super cheater? That's like great, isn't it? All right, so now from there, what is it asking for? Sine or cosine? Sine. So I'm looking for the sine. So the sine at negative 120 gave me, very good, negative rad 3 over 2. I don't even know where my thing is anymore. Is that one it? Yeah, there we go. So negative rad 3 over 2. Gotta circle it. It's that good, right? Mm-hmm. Alright, so I'm going to pull up the homework for you so you can see this too. And we are... We are 5-4, so for those few people that actually wrote down the problems that I told them to, and the others that just pulled it up on their phone or tried to, but they were, actually just looking at a TikTok video instead of actually doing their stuff they were supposed to be doing. I'm not going to cast any shade. All right, 5-4. And what was our homework problems? 9 through 21 odd. Let's look. Here's 9. Here's 21. And we know that all of them go with example 1. Right? Okay. So 9 through 21 odd, so all you need is example 1 for this. So the rest of these notes that you're going to get is going to come from Monday, your I-Day stuff. Okay, I'm not going to try and smash too much information into your brain today. We're going to stop right here. So you're going to remember to like, share, and subscribe, and hit that notification button, because on Monday, you will get a notification saying your next set of notes are available. Right? And buy my merch store.